Oh, okay. So, what's up, guys? And I'm doing Powder again. So, yeah, watch the previous video if you did not already see the problem. I highly recommend that. But yeah, I actually got a new screen recorder because my other ones stopped working in the middle of recording this video. So, it's pretty annoying. Anyway, yeah, this is the fourth time I recorded this video. So, I'm pretty sure I can get this in one shot. And yeah, let's just stop the yap. So, this is going to be a shortcut to the other solution video for Calda, and I actually highly recommend watching that one because well, it's going to give you more physical insight. This is more on like the math type of thing. It's like a no brain solution. So let's just share that to you real quick. So we're going to be using the equation of the parabola. Yeah, this is the equation of parabola. You learn this in like algebra too. So this derivation is pretty easy. So yeah. So basically the method for solving this problem using this shortcut method is basically just identifying A, B, and C through like what is possible. So for example, the first condition is that A is negative. Why is A negative? Because if you look at this graph, you see how it's concave downward. For example, let's say I did y equals 5x squared, right? This is concave upward. But if I change it to negative 5 squared, it would be concave downward. So yeah, I'm going to sketch that real quick. So if it was concave upward, this is going to be y equals 5x squared. But if it's concave downward, like what we want, it's going to be negative. Second thing is that a is equal, no, b is equal to 0. Because look, so let's say I have y equals to 5x squared plus 6x. You can see it's actually kind of offset. So like the graph of it is like kind of offset. It's not in the origin anymore. And we want it to be in the origin of the coordinate axis. So in order to achieve that, b has to be equal to 0. Because like you can try it yourself. Just write like y equals to negative 5x plus 10 squared plus 11 squared. Try to find a value where it's at the origin. And it's not possible. It's going to be always offset like this. The last 2 points are going to be extremes. So in order to find C, right, what does C physically represent? C is a value that happens when x equals 0, right? Because think about it, I plug in 0 here, plug in 0 here, y equals to C. And what is that value, may ask? It is found here. Y, yeah. So when x equals to 0, y equals VO squared over 2g. And this is not the full equation. The full equation is VO squared all over 2g times sine squared theta. But when theta equals to 90, sine squared theta equals to 1, which is the maximum value, right? So it doesn't matter. Yeah. I have a derivation of this equation on my channel. So yeah, should probably check that out. So yeah, this is going to be our C value, right? Because once again, C happens, or the C value occurs when x equals 0, and this is what happens when x equals 0. And so for now, let's just assemble everything that we have, right? Y equals to, we know A is negative, B equals to 0, and C is 2g. And the last thing we have to put together is this, R, which is range, the full range. And this gives us VO squared all over G, 0. The full equation obviously isn't that, it's VO squared. And you do like times sine 2 theta all over G. Yeah, but that's not discussed right now. You can see that derivation on my channel as well. Yeah, so this is a coordinate point, which we can plug into this equation to find the A value. So let's just plug that in. So x equals to this, y equals 0. Negative A, VO4, G squared plus VO squared all over 2G. Now if we solve for it, you put A on the other side and you do VO squared all over 2G times G squared all over VO4 equals to, just think about it, VO squared 2G. That is A, right? We just solved for it, and now we just put everything together. Y equals to negative GX squared all over 2VO squared plus V2G. And that is our final answer. See, this method really works. It is a shorter way to get Jancalda, to solve the Jancalda question. And yeah, overall, it's a pretty cool method. So yeah, smash like if you like, smash dislike if you didn't. Yeah, I'll see you in the next video.